multimodal function, as in this below case, you can able to observe that there are multiple maxima. So either when we start either from the beginning of the curve and move like this, or from the end of the curve we move like this, we normally get stuck at these particular local optimas. No doubt they are optimas, but they do not represent the overall optima in that particular region or in that particular boundary of the problem. So within the certain boundary, if we cannot able to determine the global maxima or global minima, we will be getting stuck at the local solution, and thereby it leads to incorrect partitions, and it does not give you the perfect clustering result. So that's why here our objective is to determine the global maxima or global minima thing. So giving you an example, this is a function. If you can observe that here, this is the three-dimensional surface plot of the function. This is a multimodal function in which there are three maxima and two minima. So this left side is 3D plot and right side is your contour plot. So if we are trying to determine the maxima, then it has to be here. And if we are trying to determine the minima, it has to be here. And the solution should not get trapped between these local minimums. It should not get trapped. So for achieving this particular global optimization, we are going to solve it with nature-inspired optimization algorithm. And the derivative-based approaches, I told, the steepest descent algorithm, Gauss-Newton method,
చూసిండా సార్ శ్రీధర్
Leavenworth-Marquardt method, Newton-Raphson method, least mean square method. These methods will not work so effectively in these scenarios. So what is there in nature-inspired optimization that will help us in achieving this global optima? That they do not employ single element either from the beginning or from the end, but they employ multiple elements. So these elements, they interact with each other, and they simultaneously do only one job, that is to determine the either the maxima or the minima. They possess cooperative learning, that is they share the information with each other and try to achieve the one particular goal, that is to optimize the curve or to do the maximization or do the minimization. So it is a collective intelligence of a group of elements, or we can say group of birds, ants, molecules, many types it may be. So that is what over here in this particular curve, if the element 1 and 2 could not achieve the thing, then element 3 and 4, they will achieve the global maxima, and these rest of the elements, they will follow these element 3 or element 4, whoever will achieve the global maxima at the earliest, and all of them will reach there at the global maximum. So there are many type of nature-inspired clustering algorithms have been developed over the years after John Holland invented the genetic algorithm. Genetic algorithm is the first algorithm which is, we can say, nature-inspired, and it has been applied for several applications, but I have here jotted down those papers which have been effectively used for the clustering application. So you can able to observe that in after the genetic algorithm, so over here there are single objective as well as multi-objective optimization papers have been jotted down for the clustering clustering task. Dr. Pradhan has told me to cover the single objective optimization because there is a special session for you for the multi-objective task. And there are several researchers, Indian researchers, I can able to say, they have contributed enough for the multi-objective clustering. One is Professor Kalyan Maidev, Professor Sanghamitra Bandyopadhyay, and there are many. They have contributed much to these particular developments in optimization algorithms. So these algorithms, these nature-inspired algorithms, they are categorized or grouped into various types. Among them, one of the most important is these evolutionary algorithms. They are inspired from the Darwin's theory of evolution, that is survival of the fittest, you can able to say. Dinosaurs, they do not exist today because they could not able to survive themselves with respect to the change in environment. But the human race, they have survived with the change in environment. So generation to generation, these creatures or these you can say uh, natural entities, they are becoming intelligent. So that's why whoever is becoming good over the time or survive over the time, they they survive for long. So based upon that, these algorithms, genetic algorithms, genetic programming, differential evolution, these all algorithms have been derived. Then the next category is physical algorithms. Physical algorithms, they are derived from the physical phenomena like the heating, cooling of temperature of a particular body that leads to this simulated annealing. Best approaches, harmony search, like how to fine tune musics of various melodies of various singers, so that that will lead to a good composition of music. How the beats will be synchronized optimally so that it will lead to a melodious music. Based upon that, this harmonic search algorithm has been inspired. Like that, there are gravitational search optimization, how the gravity between different particles in the planet, they are attracting or they are separating each other in a optimized way so that everything remains in balance. So like that, from the various physical uh, physical natural phenomena, these algorithms have been derived. Then next comes the swarm intelligence. Swarm intelligence is a collective intelligence of group of people, like group of ants. You know that when you put some sugar particles, then many ants will move from their hole to collect the particular sugar particles, and they move in an optimized path because they have to carry the food from the destination to their house. So then and they want to take up those loads on their heads, and they want to deliver it quickly. So that's why they always follow a optimized path, which is observed by Marco Dorigo in 1992, and he has given this excellent algorithm, and colony optimization. Then there is many multi-objective version of this ant colony optimization has also been developed and applied for the clustering application. The particle swarm optimization is another very popular algorithm which is inspired from the birds or fishes collection of food. So whenever you will observe that the if you drop some food particles in the pond, then the fishes, they will communicate among themselves and they try to grab the food. They move, they follow the leaders in that particular manner. There are many other recently developed algorithms have also been reported, like the gray wolf optimization and the well optimization based upon that. And there are bio-inspired algorithms are also developed over the time, like artificial immune system, bacterial foraging optimization. They are especially biologically inspired, how the immune system is protecting our body. So based upon that, the algorithms have been derived. uh, so those who are interested in this particular field, they can refer these single objective and multi-objective papers reported over here. So this is the overall flow diagram of the benchmark algorithms like genetic algorithm and colony optimization, particle swarm optimization. These are their generalized steps how to achieve the clustering part. So if you are following the genetic algorithm, you have to follow the crossover mutation. You have to follow the crossover mutation, fitness evaluation, and selection procedure to achieve the clustering output. And you have to repeat this process for several times. So if you can able to observe, all these algorithms are repetitive in nature. They are uh, they are always iterative in nature. So definitely in these algorithms there are some computational complexity is always involved. So for online applications, we try to develop algorithms, evolutionary algorithms, which are less complex in nature. I told you that there are statistical functions which determines the relationship between the clusters or relationship between the elements. These are the statistical functions narrated over here, which are used either as minimization or maximization problem to do the clustering task. So if you are considering these particular distances, their minimization will lead to good clustering, and these Dooms index maximization, variance ratio criterion maximization, CLOT index maximization. So there are these are the statistical functions which you have to maximize to achieve the clustering result. So the clustering as a optimization task can be dealt either as a minimization of the function or as a maximization of the function. So whenever you are going to propose a new algorithm, whether nature-inspired algorithms or any other algorithms, you have to test it on several benchmark dataset. So there is UCI machine learning database is there, and these are the certain benchmark datasets: iris, wine, glass, image segmentation, diabetes dataset, on which you can test your algorithm and justify that your algorithm is superior or inferior compared to these benchmark algorithms. So it has been applied for various applications, real life applications like image segmentation, image clustering. These all are applications of the clustering task. In wireless sensor network, gene expression, data analysis, uh, web mining, text mining. There are several of these nature-inspired algorithms like GA, PSO based algorithms. They all have been applied over these to solve the particular task for the clustering. So you can also develop these real life applications. So this is a review paper our group has published, and you can refer more details for this particular paper. And now I will be focusing on a recently developed algorithm on nature-inspired optimization algorithm based on social spider optimization. Inspired behavior of the spiders residing in a particular colony. So you know spiders, they always create a wave, and they on uh, among their generation on the wave, they they characteristics of male whenever a dominant male spider is there among the group of female spiders in his mating radius, and this has been implemented also in this algorithm. So initially, as it is a swarm-based algorithm, so we have to consider a number of spiders. So if we are considering 10 spiders, then out of that, the number of female spiders are around 70 to 80%. So first we will declare 70% of the population as female spider and 30% as male spiders. Then we will calculate the fitness evaluation for clustering. I have already discussed in that table around 10 functions which are either maximized or minimized to achieve the clustering. So here every particular population, spider population, they represents the cluster centers. Each of the spider, they represent the cluster centers. So now from the dataset to the cluster center, we establish a relation that is either a minimization relation or a maximization relation of the statistical function. So over here, the minimization of Euclidean distance can be taken as one of the thing. Then we have to assign weight to the spider. Suppose there are 10 spiders have been considered, so each spider weight we have to calculate how fit the particular spider is. So this weight can be calculated by considering the fitness function. So we have calculated the fitness over here, the fitness evaluation for each particular spider. That is one particular spider, if we are considering it as one type of cluster centers, it is representing the cluster centers, how effectively it is giving the clustering result. That signifies by that particular fitness function. So from this particular fitness function, we calculate the weight of the spider in the colony. Then for every spider, this particular weight is calculated. And among the male spiders, that is the 30 to 40% male spiders are there, who we calculate the mean of the weight. So if the any particular spider weight is more than the average weight of the male spider, then we are saying it as a dominant male spider. These dominant male spiders, they are responsible for sexual interaction with the female spider, and through which the baby spiders get produced. And the non-dominant male spiders, which average weight is less than the median weight of the male spiders, they normally lie in the central part of the web, and they are responsible for exploitation of the optimization process. And only the female and dominant male spiders, they are responsible for exploration of the search space. So this there a good optimization algorithm has to keep in balance between the exploration and exploitation process. So the beauty of this particular algorithm is that every individual spider has to communicate with its nearby spider, that is the local spider, and it has to also obey the global spider relation, that is the healthiest spider in the particular community. SL is the local spider and SG is the global spider over here. So, with these two particular relation, we can able to observe that these relations are nonlinear in nature. If we compare this particular update equation with particle swarm optimization, in particle swarm optimization there is no nonlinear relation is there, but here this nonlinear relation is there. E to the power minus delta SI SL square. So that makes the traveling so effective in the nonlinear space. So, and this nonlinear relation has been established, it has been derived in such a way that it is assumed that when a particular spider punches on the web, then this particular thing get communicated to the rest of the spider. So if a spider is a healthy spider, it can punch on the web and create vibration, which will get diminished with respect to the distance. So initially, if a spider punches heavily, then it will create a heavy acceleration like this, and it will get reduced with respect to the thing. And that this particular thing of reduction is exponentially decaying with respect to the distance. So as the distance increases, this exponential decay phenomenon will also increase. So this is what the impact e to the power minus delta SISL square. So e to the power minus delta, this delta is nothing but the distance. So e to the power minus thing, so this decreases with respect to the distance. And that is what the vibration received by any individual spider from the local spider and from the global spider, as well as from the female spider. So the for the exploration of the thing, the female spider movement is defined by this particular equation, in which all the if you can able to observe, if rand is less than this pf, pf is female socialization behavior, then if a random number generated is less than this pf, then all the above factors of alpha beta they are positive, otherwise they both of them are negative. So a particular spider that will move, a particular female spider especially, you can able to observe this is F and F. So it will move towards the local spider as well as towards the global spider if its socialization interest is there, its mood is good, its socialization interest is there, then both these factors will become positive. Otherwise, if it do not want to socialize itself, it want to make itself isolate, then it will deny both the factors from the local as well as from the global vector. So both the things, both the update equations, you can observe both the update equations are negative on the this particular equation. So that is how the movement of the spider occurs. And the dominant male spiders, they move towards the female spiders for the mating purpose. So over here in this particular update equation, you can able to observe that this female spider to the dominant male spider, the relationship has been established over here. And that is what the update of the spider movement. In both the equations there is random numbers also do play a role, so a random phenomenon has also been associated over here. Then the exploitation part is taken care by the non-dominant spiders, which lie almost around the central part of the web. So you can able to observe that these non-dominated spiders, so this XW is nothing but the average weight of the position. So the average weight, so the non-dominant spider movements towards the central location is explained over here, and they help in exploitation process of the algorithm. Then the important aspect of the algorithm regarding the mating process. This particular mating process, in this spiders get produced, which takes care, which takes the good position and replace the spiders which have worst fitness. So over here in the mating process is defined over here. Suppose there is one male spider and three female spiders. I'm in a class. It will get finished at 1 o'clock. I'm in a class. So over here there is one particular male spider and three female spiders are there. So there are total four spiders are taken in the example S1, S2, S3, S4, out of which one male is there and three female spiders are there, F1, F2, F3. And this is their position and weights. So the particular spiders probability we can able to calculate it by making sum of all these things, zero point 0.4, zero point 0.3. So how to calculate the weight? Weight is nothing but it is calculated from the fitness of the position. So the position of the spider is known. From there we can able to substitute this position in the fitness function, and we can able to calculate the fitness of each particular spider, and from the fitness we can able to calculate the weight of the spider. So from these weights, we can able to then calculate the probability of each particular spider. So this probability summation of this, so zero point 0.4 divided by 1.490 is 0.26, 0.3 divided by 1.490, that is 0.19. So this is the probability percentage we have calculated. And among this probability percentage, if you will observe F2 is is having the highest probability, that is 36%. So F2 probability is highest, and F2's position and weight, that is the best position among this one. So that position has been taken by the new baby spider. So the best position is taken by the new baby spider, and the worst position get discarded. So thereby the algorithm try to eliminate the worst fit solution and try to make it enrich with the new solutions. So this is the original social spider algorithm in which the female update equation of dominant male update equation and non-dominant male equations was run sequentially and the machine mating process was carried out. But in the updated we our group has proposed this updated algorithm, that is the parallel social spider algorithm, in which the update equations are allowed to run in parallel uh, and thereby save the computational complexity of the algorithm. We have used the parafor looping and divide the entire thing into multiple cores and allow to run each of the segment in different cores and thereby reduce the computational time of the algorithm. And we have applied it, tested it on various benchmark data set, that is low dimensional data set and some of the high dimensional data set. You can able to observe that KKD COP data sets also we have tested on, which the class size are also varying between 16 to 10 to more number of clusters. So this is the analysis over here, the classification error percentage. We have compared the thing with the artificial bee colony algorithm by the Davis Caravaglia, which is very popular algorithm. And also we have compared the results with particle swarm optimization, real coded genetic algorithm, as well as with k-means clustering algorithm. We have applied these algorithms and observed the thing that in some of the data sets we are getting better result. That is iris. Both the algorithms are giving better iris wine. Both the algorithms are giving almost 0 0 as classification error percentage. You can able to observe. In some of the things, ABC is better. In some of the things, this SSO result is better, like in glass, horse, all these data sets, the result of SSO is better. In this credit card and heart case, the ABC algorithm result is better. So this is the result of KKD COP data set, in which the clustering results with SSO, they are giving us more effective distinguished patterns or some more separable clusters compared to the rest of the algorithms, in which the clusters are almost overlapping in nature in most of the cases. So if we will observe the computational time thing, so compared to the original SSO algorithm, which is computationally expensive, this we have saved a lot of computational time for these data sets. So instead of the 44 second, we are obtaining a 25 second. Here for the handwritten dataset also, the computational time is decreased. With classification error also, we have improved with the parallel SSO algorithm. So here there is another very important application of this particular algorithm is we have applied it on the analysis of a flood affected area of Chennai. In 2015, there was mm, in the month of October, there was a flood in Chennai in which the aerodrome area has been submerged. And here we have tried to identify the water retention after the flood and before the flood with this particular algorithm, and you can able to observe how the river banks and the other areas the amount of water has been drastically increased. So compared to this lake, you can able to observe this of this lake, and here there is this particular portion is the path of the river been increased over here. So that if a timely identification of this particular analysis can help the um, uh, evacuate people from these areas so that they can be saved from the floods. So that is what the interpretation over here. So these are some of the publications of our group over the year uh, on this particular thing. I will be happy to take some of the questions on the topics I discussed. If there are any queries. Uh, yeah, there are some queries, I believe. Dr. Pradhan, can you help me to find it out about the queries? Yeah, uh, Ravi Kumar is asking that how to design an optimization function. Can you share some observation inside? So for designing an optimization function, there are several functions or statistical functions are there. So let me share this particular slide. So this is about the various statistical functions that has already been there. So this CILUT index is already, if you are using a MATLAB toolbox, then this CILUT index is already their CILUT function which you can use. And for the rest, Dunes index, David Boden index, and CS measure. So these three statistical function mathematical analysis is already given in this particular survey paper. So you can refer the mathematical expression of these three functions, and you can able to calculate them. And these are the medoid distance, centroid distance, and mesoton distance. These all the rest of these functions mathematical analysis is also given in that particular paper. So you can able to express the function and calculate the fitness function for the same. And these papers also I have already included. You can refer these papers. So all these references I have given, they are already there in this particular review paper, and either you can follow this particular review paper or directly follow this original author's paper, so that you can able to determine the fitness evaluation and the cluster validity index, which are the function to be optimized, maximized, or minimized. I hope if there are any more query.
I think there is one question from Christian de Kumar.
Yeah.
It's written in the chat box. How to select a proper optimization algorithm for a given problem? Is it data dependent?
uh, which is data dependent, right? So about the,
Is it data dependent?
yeah, so which is data dependent, especially for the data dependency, you have to you determine. First thing is the number of clusters present in the data. If you are if you have a completely unknown data set, then first try to apply a hierarchical clustering algorithm. The hierarchical clustering algorithm will give you how many number of clusters are there in the data set. So from there it will be little bit computationally complex, but you will get an overall idea that how many number of clusters are present, inherent patterns are present. But that particular thing will give you a fixed result, that it has some 3 or 4 cluster and these many number of points are there in each of the clusters. So from there you will have the get the idea that 3 clusters are there or 4 clusters are there. So once you obtain that particular crisp result, then you apply the your particular any of these particular statistical technique, and then try to explore about the mm, nonlinear characteristics, and maybe you can get much more result, much more better result than whatever the hierarchical algorithm will give you, because the inherent data may be nonlinear or overlapping in nature. So but for that one you need to first identify how many clusters are present, and then accordingly you will select the particular thing. There is, I think he has written another question for the thing. Actually, when I am sharing this thing, I cannot able to read the chat box. If I stop
Okay.
sharing, then I can able to read the chat. So
I think you
no,
can
no,
stop
no,
sharing.
yeah,
That's not a
yeah,
problem.
yeah. I got the chat box. Are there any open source implementation of these functions, sir? Please share some resources for a newbie. Okay, there are open source implementations are there in the R as well as in Python. So if you will be using the Python, then the all these functions of k-means and dbscan, they are code is available to you, and you can able to use their package directly. But in MATLAB, but this CLOT index is there, as well as the k-means is there. But for rest of the things, you need to write the particular function. If you are using open source software R, then in the R there are many of these functions codes are also available. So based upon the platform which you are choosing any open source, I believe Python and R are good. And if otherwise, SPSS is another also very excellent platform, and many researchers from humanities, they are using this SPSS software. Of course, that is not open source, I can say. Like MATLAB also, they do have the copyright, but there are also many of these clustering techniques can be effectively used. So, is there any more question?
Any more questions from the participants?